All right. So can you guys hear me now? Okay. Thank you everyone for connecting today. This is our third session in the row. So these sessions are going to talk about very basics of the technology. So the agenda is we will start from the basics and bring everyone on the common ground. Everyone knows the basics of technology, basics of networks, computer networks, network security, data protection, cloud computing, cloud security, everything. And then we will do deep dive session on each and everything. So some of the classes may or the sessions may run in parallel, or we will do one after another. So hang on for that and stay tuned. So we have live chat enabled. If anyone has any questions, any problem with the audio or video, please type the comments on the live chat and I should be able to answer there. All right. So the topic for today, which we are going to talk about, is cloud computing. All right. So before this, there were two sessions. The first session we had was on overall introduction about what we are going to do in these classes, and there we talked about the basics of everything. And the second class, which happened on Tuesday or Wednesday, and we spoke about network security and computer networks there. So this is the third class about cloud computing. We are going to talk about the basics of cloud computing, and then what are the characteristics, what are the deployment methods, what are the benefits of cloud computing, what are the challenges a typical organization sees while adopting a cloud computing solution, all right? And what are the solutions to those challenges? What are the security concerns before you move to the cloud? So these are the things we will talk about, and in the end, we will conclude the session with the takeaways. So in our last class, I gave a puzzle in the last presentation, and the presentation was shared with all of you. So whoever could find the answer of those puzzles, please type the answer in the chat. So we'll see how many of you got it right and how many of you got it wrong. I think the chat is not working. Let me just check if the chat function is working or not. One second, guys. All right. So the chat is live there. You guys can comment there, I guess. Okay. So I see Sahil, Umesh, Amreen joined the session. Hi everyone. Okay, so slide number 3. So what is cloud computing? You might have heard of this term a lot of time, and this is not a new term. The cloud computing was started in 2000, but then it boomed in late 2000, like 2010 or something. But people started adopting, and the company started coming up with their cloud solution in 2003. So what is cloud computing? Why this is talked? Why this is a hot topic now? Why everyone is talking about cloud computing? So in our traditional days, even some companies are doing that right now as well. So we used to have data centers, and the data centers were huge. Were a huge had a huge requirement of cost in terms of the electricity they needed, and people needed to buy physical devices, and you need to buy more resources and then you need to accommodate the spike in the requirement. You need to have multiple data centers to maintain the disaster recovery. So there were a lot of challenges, and then you needed manpower to handle the data center, right? So that was a lot of cost. And then from operational perspective, it becomes a challenge. So now the internet is changing our lives. So we see that the demand for the resources in our data center may be huge on one day, and for the rest of the year, it's very low. So that's one of the challenge where we need cloud computing in place. We'll talk more about those things. So let's start from the basics, the definitions and all. So cloud computing is a general term used to describe new class of network-based computing that takes place on internet. What we are trying to say here, let me enable this. So what we are trying to say here, it's like you have the resources, your data center resources in the cloud, which is not on your data center. So what happens you if you need a CPU, right? If you need 5 servers, for example, right? You don't need to have a data center. What you do, you buy a license from one of the cloud service providers, typically AWS or Amazon Web Services or Microsoft Azure, and then you create servers there. So you only pay for the amount of CPU or memories you are taking in those servers. You are just you can again increase the resources on the go, right? So this is a network based computing that takes place over the internet. That's the general term for cloud computing. We'll talk about the standard definition as well from the NIST, what NIST says about cloud computing. We'll check that out on the next slides. Okay, so it's basically a step on from utility computing. Utility computing is nothing the same as we used to have um, our traditional servers and all. So it's just a advanced version of that, a collection of group of integrated network hardware, software, internet infrastructure, and platform. So if you know that our developers, they work on a lot of things, like they work on the platforms to develop the codes. They work on the platforms to test their codes, and then they have Jenkins and other software to deploy those solutions. Earlier everything was in their own data centers. Now you don't need to buy anything. You can use the services from other providers as a platform, as a service, and build your code, develop your code, run your code, and test your code, and then go live without owning any hardware. So that's the point number two. And point number three is using the internet for communication and transport provides hardware, software, and networking services to client. So this means you are using internet to communicate to your devices, your servers, your hardware devices, which are sitting in somebody else's data center, your software, which is hosted on somebody else's network, your network services like your VPN, which is your VPC, which is actually hosted on AWS network. So you are basically using internet as a communication method to talk about different services. So if we summarize three things, cloud computing is a general term which talks about the virtual resources owned by you, which are dependent on the pay as you go or the metered billing, where you only pay for the resources you are utilizing. You can subscribe for the platform which you need. There can be three type of platforms: hardware, software, or the infrastructure. We'll talk about these later. And then you use these services over the internet. So by using this platform, what happens, you are not bothered about the complexity about the backend data center, right? So you don't really need to know how many physical servers are there, how the connection is happening in the backend, what kind of cables are being used, right? And then what kind of virtualization technologies are used in the background, and how many people are there to support this infrastructure, how big is the environment, the data center. You don't really need to worry about that. All you need to worry about that I need a server which has 8 core CPU, 8 gigabytes of memory, 500 terabytes of disk space, or so on and so forth. So this actually hides the complexity of the underlying architecture from the users and the companies. So you are really not bothered about much of the complexity the hardware requires. So your main focus becomes on the useful things, the productive items. So now you will be spending more of your energy and your money on the items which are more required from the project perspective. So you can spend those resources, those manpowers at the correct place. Okay, so let me open my chat here 1 second. Okay, so I'll look at the chat in the end. If you have anything to say, please type there. We'll check it periodically. Okay, so again, it's the same thing. Cloud computing is internet-based computing where shared resources, software, and information, shared resources like software, information, and platform are provided to companies on an on-demand basis. So there are two terms. One is on-demand basis, as you see here. One is pay-as-you-go. Okay, and then the third term is metered billing. So these three terms they will be used a lot in when we talk about cloud computing. We'll be using them very often in this class, and when you talk to somebody else who works on the cloud, they will be using these terms a lot. For so what this means, the on-demand basis, like whatever is your demand, you pay for that. You don't pay for something which is not which you are not demanding. So for example, your requirement is to have 10 servers, right? But you say if my CPU uses go more than 10 servers at any point of time, right? If I need more servers than 10, then automatically there should be another 10 servers should be created. So until at the time when you were using just the 10 server, you are being paid only for the 10 servers. And when this spike happened, when your 10 more servers automatically were created based on the script you created, then you will be paying for 20 servers, 10 additional servers as well. So this is the demand which was increased, and so your bill increases. So you don't always have to pay for the 20 servers, you just pay for the one you actually need. And when the requirement increases, you pay more. So again, the same term, pay as you go, and the metered billing, it's the same thing. So in a layman's language, if we look at our traditional resources like our electricity and the water bills, right? So how do we pay those bills? We only pay for the amount of water we are consuming, or the amount of electricity units we are consuming, right? And then at the month end we get the bill and we pay that bill. So same thing happens in cloud computing. And the next point is just it's just saying that it's an effort where the companies provide you large scale computing abilities to seamlessly access limitless virtual resources. So what they mean that you actually don't own anything, right? You don't have any hardware, but virtually you have a capability to increase your environment to a limitless environment. You can from 10 servers to 10,000 servers, you can just scale up any point of time. So that's the flexibility you have. That's called large scale computing. So in large scale computing, your individual servers can be having maybe having more CPU specs, right? They can be having like let's say 16 core of CPU or 50 core of CPU, and instead of 16 gigabyte of RAM, you can have 50 gigabyte of RAM. So then again, that there are different kind of pools of the CPU and the servers which are created on these platforms. And then you select which one you want from which range, and then how many of these servers you want. So it's just how much you can afford. You can pay for that and buy those servers, and whenever you don't need, you can terminate those servers in just one single mouse click. You don't need to send an email to them and ask them to delete those servers for them. No, you don't need to talk to anybody. You have the portal with you, and you can just click on create server or delete server whenever you need. Okay, now there are three main characteristics. I won't say characteristics, but these are three properties of the cloud computing environment. These are remotely hosted. These are not hosted on your environment. These are remotely hosted somewhere else. And these are ubiquitous, means services and data are available from anywhere. Means even though the data center might be sitting in Chennai, people sitting in Bangalore should be able to access, people should be sitting in US should be able to access, and people sitting in Germany should be able to access. It's a seamless access to everyone. There are a lot of technology behind that, how even though the long distance communication doesn't impact, one of the way they handle it, they use CDN. CDN is called content delivery network. So what happens when somebody accesses this data from the internet? Let's say you have a website hosted on AWS. So if somebody is accessing that service from another location, the data from Chennai will so for example, if you created a website in Chennai, right? You're actually the data is in Chennai, but the user is in Germany, right? So when somebody from Germany tries to access the data from Chennai, this request from Germany gets initiated to it goes to AWS server in that particular region. AWS server requests that information from Chennai server, and this Chennai server, instead of serving it directly to you, this information goes to AWS hosted server in Chennai in Germany, and it creates a cached copy of that particular information, and then it gives that information to you. So the next time somebody else requires that information, it doesn't actually talk to Chennai because it already has a cache of that information. It just serves that information to another user. Now that actually depends on whether it's a static data or dynamic data. So some requests may need to be refreshed, or some may just can be just simply provided to the user. Okay, so the third point is commodified. Commodified is nothing. It's the same thing which I just explained you in the last slide. It's a like the billing is like what traditional utility bills like gas, electricity, and water. Pay for what you would want or pay for what you consume. So they are just these platforms are just converting the computing requirements into commodities, and you can just use them how you want, how much you want, and when you want. Okay, so the next slide says data center is the new server. So what do we mean? If you think for a minute, earlier in our data center, how many servers used to be there? Right? We used to have around 200 or 250 servers in one data center. When I say we, I'm talking about the companies who used to have their own data center. So in typically a company who will be having a data center, they will be having around 250 servers or 200 somewhere that, right? So now that much capacity of that much servers, right? 2250 servers, right? That load can be handled by just one single server in the cloud. So you don't need 250 servers, you just need one server. But there can be different reasons where you need to spin up more servers for the backup, for the disaster recovery, right? And for the scalability, for the load balancing. There can be multiple reasons, but that's the actual theory behind it, that in one server can handle the load of entire data center what earlier used to be there. So if you look in the picture, this is a picture I got from the internet. It's a very beautiful picture. It shows how the cloud has changed our life. So you look at this, what you are seeing in this picture is a data center of one of the service providers, one of the cloud service providers. This is, let's assume this is their data center, and all these boxes you see right here, right? This is just an enlarged image of that box, what you see inside that box, what is inside that box. So these are again the same box. It shows that one of these box is a container. Okay, each box is a container. Container is like what trucks carry on their back, right? Shipping containers. So each shipping container has around 2,500 servers, which is about 10 times of the conventional data centers. So if this one truck is carrying 10 data centers, if you look at that way, okay, and each container it can integrate with computing, networking, power, and cooling system. So this means this is just a computing. Okay, now you need to connect it with power, with the networking and cooling system, right? Cooling is very important because such a huge load needs to be cooled. So these systems you see here, right, these are supplying water to these data centers. These are water systems, and you see here, this is the cooling system, how these servers are being cooled. So this is a water based cooling system. Then power, there is a huge requirement of power. This is around 300 megawatts of requirements to the power for the power. So this is almost a supply of the grid. So how much our grid supplies, right, from one city to another, how much one city requires power, that's the requirement of these data centers. And then structure wide, these are very large facilities, very large, right? So now you can see one container has around 2500 server, which is around 10 data center, and you can see how many of these containers are there. So look at the capacity of this data center, how much it can provide you in terms of cloud computing power. Okay, so in terms of the definition, if any one of you is going to write an exam, this is what you need. NIST is an organization which defines the standards for the data security, network requirement, data protection, and all. So any company has to adhere to NIST standards. This is what NIST says about cloud computing. This definition was released in 2011 by NIST. So NIST says cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resource. Right? For example, networks, servers, storage, application, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model is composed of five essential characteristics, three services models, four deployment models. So when you talk about cloud computing, you need to know these five characteristics. We will talk about these five characteristics. Okay. Three service models. What are the three service models? And what are the four deployment models? You need to know these things. If I missed to cover any of these, make sure that you go to Google and then you read about these things. What are the five characteristics? What are the three service models? And what are the four deployment models? NIST also defines the keywords typically used in the cloud computing environment. So we typically see SaaS, SaaS. This is pronounced as SaaS. So SaaS is secure software as a service. Then PaaS, PaaS, platform as a service. Then IaaS, IaaS. This is all pronounced as infrastructure as a service. Then you have on-demand self-service, reserve pooling, rapid elasticity, measured service, software as a service, platform as a service, infrastructure as a service. So these are the keywords which were used to be used in 2011. Now we have more keywords coming in picture like security as a service, DevOps and security as a service. That's called DevSecOps, and logs as a service. That's called log AS or LAAS. So now you can call anything as a service, and that typically means a cloud based resource. So now I'll give you some of these examples: what is SaaS, what is PaaS, what is IaaS, on our next few slides. If you have any questions, please type those in the chat and we will cover those in the end of the session. Okay, let me check my audio. Okay. So again, from as this is a model which NIST has released when they talk about the cloud computing. These are the things we talked about. Five essential characteristics of the cloud computing, which is broad network access, rapid elasticity, measured service, on-demand self-service, resource pooling. So these are the five characteristics every cloud provider, no matter if they are SaaS provider, PaaS provider, or IaaS provider, they have to have these five characteristics. Okay. Then there are three type of deployment methods: delivery models, software as a service, platform as a service, infrastructure as a service. And then there are four type of deployment methods: public cloud, private cloud, hybrid cloud, and community cloud. So this link on top, it's actually your old link. I don't think it works anymore. You can use this link given on the bottom for the definition of cloud computing. And by the way, I already shared this definition on this slide. Okay, so what do we mean by resource pooling or virtualization? So this is this is how our traditional resource pooling used to look like. This is how our traditional software stack used to look like. So you have a hardware server. On top of that, you have an operating system, which can be an Windows, Linux, Mac, right? Any server. And then you have applications or the containers running on top of these operating system. This is how the traditional servers used to look like. Now the current environment looks like this. So you have a hardware, on top of that you have hypervisor. Now that hypervisor, what it does, it lets you create multiple operating system on one single hardware, and then you run multiple application on each operating system or individual application on uh, each operating system. So what is hypervisor? Hypervisor is just a terminology or a technology which allows you to create virtual servers on any hardware. So if you have seen, like we used to use VMware on our machines to install a virtual operating system where we can do some testing and all. It's a similar technology but done on a large scale where we have the big servers set up in our data centers or the cloud service providers data center. And these servers, like, so if you look at the disk space, these disk space are like quite big. If we need 1 terabyte on one server, then the hard disk which one server will be having here will be 10 terabyte. So we can create 10 different servers, and each server will have 1 terabyte of disk space in its own. So same thing goes to when we talk about memory and the CPU as well. So now you see the difference. Just introducing the hypervisor, it makes it virtualized stack. And that's what the cloud service providers are doing. They have large hardwares on top of that they do virtualization, and on that virtualized environment they install different kind of operating system as per your requirement. And then on top of that you run the application. Okay, this is just again a different image to explain the same thing. So there are three compare with this image here. Okay, so there are three delivery models, right? SaaS, PaaS, and IaaS. That's what is being explained here. Application means SaaS, platform means PaaS, infrastructure means IaaS. So these are the three main areas of cloud computing service models. So in these service models, the applications can be these kind of application. It can be a monitoring application like Splunk, Cure, or ArcSight. Then you have content. This can be like Facebook, Instagram. You have collaboration like your Skype, WebEx, or Teams. Then you have communication. So again, Teams comes here as well and here as well. So Teams, then Slack, this they all fall here. Then financing softwares. So under platform you have like your containers, Dockers, and the applications which are used by the developers to develop their applications. Then you have the infrastructure as a service where you have compute as the CPU, memory, hard disk space, etc. Then you have block storage. This is a storage where you store your data. Then networking to connect those in systems. Okay, so we talked about three service models, right? SaaS, IaaS, and PaaS. We have covered this area of the NIST definition. Now we are going to talk about these things. Essential characteristics of cloud computing. So, yep, on-demand self-service. This means you have the full control with few clicks of the mouse. You can create your own server, delete your own servers, and scale your own servers. Then next comes resource pooling. So I will give you time to read this and then I'll explain this. Okay, so resource pooling is what happens in our traditional days. If we need 10 servers, right? We used to buy 15 servers to make sure that if any of these servers go down, we have another 14 servers. If five of these go down, we have 10 servers. So 10 is the basic requirement. So we are reserving 15 servers where we needed 10 servers, and we end up buying the 15 hardware for these 15 servers, right? And so same thing happens when we need more resources. Earlier we needed a resource which only needed to manage 10 servers. Now he need to manage 15 servers. Probably we need to hire one more guy. And then same goes to all other requirements: power, electricity, and the uh, the bandwidth, everything. Now what happens in resource pooling? Resource pooling says that if you what happens, so you utilize your resource requirements. So if you have a requirement of 10 servers, you create 10 servers. Then you just create a policy. Instead of creating another 5 more servers, you create a policy that when my CPU utilization goes more than this, or one of my server goes down, or 5 of my server goes down, you spin up this many of new servers, and that gives you more resources. So you are pulling up the resources when required, and you are freeing up the resources for the other community members when you don't really need them. So this is a shared model where you only reserve the resources which you need. You don't actually hoard the resources so others don't face problem while when they need resources. That's a model of resource pooling. Okay, now the third term is rapid elasticity. So the systems change very constantly, and that creates a bad experience in the users. So IT department often they need to scale their systems, they need to update their systems, right, to meet the user requirements. So if we take a classic example, earlier we used to have the Windows 2012 servers. Now we have 2016 server, right? And if we talk about our end user machines, we used to have Windows 7 machines, and now we have Windows 10 machines. So Microsoft and has ended the support for Windows 2007 and 2012 servers. So that means you need to update all your servers, all your desktops to the latest version, right? So that's a lot of headache. Now it's possible that the resources you bought to handle this requirement, your hardwares were only supposed to take care of 2007 or Windows 7 or 2012 server. Are not capable of enough of handling the new system, right? In that case, what happens? You have to throw all of your old systems and buy a new one. That's a huge cost, right? And at the same point of time, from the user experience, they may be having a lot of data on those systems, and a lot of configuration might have been done already by on those servers. Everything goes into waste, right? So in terms of when we talk about cloud computing, you don't have to worry about any of those. All of your resources will be my you what you need to do, you just create new services by just clicking couple of buttons, and with the latest image of the operating system you want, and then you can do migration of the data from the old machines to the new one. That's very easy, and the user will not even see a difference in their activity earlier and the now. The next term is broad network access. So broad network access earlier was like traditionally, if you have to install a software in your machine, right, or upgrade your system to handle a program, what used to happen, if you are away from your machine, you cannot access your machine, right? So let's take an example. If you have a physical server in your infrastructure or a laptop at your home, if you need to install a new software or update your existing software, what you have to do, you have to sit in front of that computer and do the upgrade, right? You don't have that hosted on the internet, you can't access it from anywhere. However, you can run some softwares like Teamweaver or some screen sharing tool which lets you take the control from the internet, and then you can make changes. But that's not very helpful when you have 15 or hundreds of servers or hundreds of machines to take care. Now, when we talk about the cloud computing, these servers are hosted in the internet, and with just few clicks, you can take control of these machines from anywhere. That gives your IT team broad network access. They can access this machine from anywhere, and if there's something goes wrong, they can fix it on the go. So, if you look at the current situation in the world, we all are working from home. So is our IT teams, right? We all are working from home. We have our laptops and which are not connected to the network directly. We have VPN, and then we have our infrastructure which is hosted somewhere else. A lot of time these now the companies are not hosting their own data center, they are using this cloud computing based resources. So we have that flexibility of connecting from anywhere, or work from home policies are not impacting our actual work at all, right? So that's a broad network access thing here. Then next comes measure service. Measure service is nothing, it's just like you can scale up or scale down based on the requirements. So if you look at the definition, it says cloud providers charge IT department based on the use of their computing resource. On the other hand, IT department can use these metering or measured services to scale up or scale down. So what it says, again, this is the same term we used earlier, right? Measured services, pay as you go, metered billing, on demand services. These all are terms for the measured services. Different cloud providers use different terms, so don't get confused. Whenever you see these five terms, they all mean the same thing: pay as you go, on demand basis, Metered billing, measured services, right? These are the same thing. How much you utilize, that much you need to pay. That's all. And if you need to scale up, scale down, according to that, the new requirement, what you are posting, you need to pay the more money. That's all. Okay, types of cloud computing. So we have explained this earlier. I won't spend much time. Three types of cloud computing: software as a service, IaaS, and PaaS. Software as a service, platform as a service, infrastructure as a service. Okay, so again, just the same thing. When you use IaaS, when you use PaaS, and when you use SaaS. So IaaS, infrastructure as a service, is which lets you run your workloads, your servers, your data center in the cloud. IaaS providers are those. These are called infrastructure services. So somebody is giving you this infrastructure service in a virtualized manner. Those are called IaaS providers. The typical providers are Amazon, Azure, and Rackspace, Google Cloud. Okay, then comes platform as a service, right? um, Platform as a service is they a lot of time they provide you API to use their platforms, right? So Kubernetes, Dockers, containers, these are the typical platform as a service which are used by our developers and other teams, where they build their codes and run the codes on that. So if you belong to an development background, if you are a coder, you may be knowing these technologies already. So some of the example which are of these providers are Google App Engine, Force.com, Red Hat Softwares, Oracle App Development, and Azure. Um, and then you have AWS Beanstalk, Elastic Beanstalk. Then next comes software as a service. So what we say, first thing, look, in the IaaS, providers are giving you the very basic layer of the infrastructure. They are giving you the servers, right? Then comes the platforms as a service. So platform as a service, they are giving you the applications hosted on top of those servers. Then comes the software as a service. So software as a service is the another layer on that particular diagram, where it's a third thing, which is so first comes infrastructure, then comes platform, then comes the software. So softwares are actually running on those platforms, running on those virtual operating systems. So typical examples are Gmail, Salesforce, Yahoo Mail, NetSuite, OneDrive, Google Drive, Dropbox, Box, etc. And on top, I have written, why do it yourself when someone else can do it for you? So this is a typical method which is used in the organizations, that you don't want to invest more resources in doing something which somebody else has already done and they are willing to do it for you. So utilize the resources wherever you see somebody else doing it for you. Okay, so the next slide, this is actually a pretty interesting one. I'm not sure if you can see it clearly or not. I'll just zoom it a bit if I can. Okay, there we go. So see, so in our traditional, so what we are doing, we are comparing our traditional infrastructure versus the current infrastructure. So in our traditional infrastructure, we used to own the data center, and in that data center, all the infrastructure like the hardware, the operating system, the memory, the disk, everything used to belong to that particular company. On top of that, we run the platforms, right? The engines to develop our codes, the Dockers, containers, right? Kubernetes and everything. And on top of that, whatever is application we need, you used to host those applications in our data center and use it by yourself. So if you see a typical example, a purchase, an invoicing system earlier that used to be bought by the companies like these malls, what they used to do, they used to have a data center where they install those billing softwares, and then their terminals connect to their data center directly. So that's a huge cost they used to spend in these things, right? And now let's see how it changes with the cloud. So now when you have the cloud, in the cloud, you can just outsource the infrastructure to the cloud. So on the right side, you have the cloud. You hosted the infrastructure in the cloud, and then you are running your platform and your application on your own network. Okay, so this is actually running on top of this infrastructure, but what you are managing is platform and application. You are not managing the infrastructure. You are not bothered about the complexity of the infrastructure. Then comes the PaaS. In the PaaS, what you do, you buy the hosting of infrastructure and platform from somebody else, then you run your own applications on top of it. So this is like the Dockers and Kubernetes and the containers. They are hosted by the Google's AWS and Azure, and then you just run your applications on top of it. Then comes the SaaS, where all these three things are outsourced by somebody else to you. So what you know, Salesforce.com or Google Drive.com, OneDrive, Microsoft Office 365. These are the software as a service which are just hosted where the infrastructure, platform, and the application all are hosted by the service provider, and you just use your internet and the browser to connect to this service. You don't typically do any of the management in your environment. So this is a pretty good comparison between the traditional environment and the new one. Okay, so Forrester, this is a new term for you guys, I guess. So Forrester is a company which does a lot of research and based on the technology, and then releases their white papers every year and basically every quarter. So what they are saying that cloud market will reach around 241 billion by 2020. So I think these limits are already passed. If not, then it will be passed soon. So if you look at the requirements, in 2008 the requirements were here. Nobody was using cloud, and then suddenly the requirement, the blue represents the infrastructure as a service. So the requirement for infrastructure as a service just started growing here. From here it became very constant. And but the dynamic infrastructure service, this is again extended mode of IaaS, which began extending from here to here. So this is completely IaaS. Then you have PaaS here. So see from here 2008 to here, it's a huge growth, right? So these are the this is in the billions of dollar. So right now, if you look at this graph, you can understand that why the cloud is very good to know for you, why it's the hot requirement in the market. The more number of people adopt to the cloud, the more jobs will be created and more resources will be required. So earlier companies never used to provide work from home, but looking at the current world market, companies are encouraged to give their employees work from home, and so we have the requirement of having the data in the cloud, having the data centers in the cloud, and having our applications and containers and everything in the cloud. So that gives us more opportunities now when we talk about cloud computing, cloud security. So if you haven't moved your infrastructure, or if you are looking to change your job into cloud, this is the right time for you to do that. Okay, what is the different in the cloud? So as we change our architecture, when we move from our traditional environment to the cloud computing, so comes the security. So needs to be the security needs to be changed, right? So if you are just using a software, not as a software, the software as a service solution, like if you are just using Microsoft Office 365, what's your responsibility? You just need to secure your data on hosted on the top of that application, right? You don't need to worry about the platform and the infrastructure because that's not managed by you, that's managed by the service provider. So the shared responsibility, there's a common term used in the cloud environment, share responsibility model. It means the half of the responsibility of the data security for the items owned, for the infrastructure and platform owned by the service provider will be theirs, and the rest of the security responsibility for the data and other things owned by you relies with you. So you need to be sure that whatever is in your control, you provide enough controls on that. You have enough control. You secure your network. Whatever is in control of the cloud service provider, they secure it, right? So if you are buying IaaS service from somebody else, then the platform and the software that's owned by you, right? So security of platform and the software relies with you. You need to secure them. When it's platform as a service, the security requirement from your side reduce because you are just hosting your application. You are just outsourcing your platform and infrastructure from somebody else. So the security requirement of platform and the infrastructure relies with the service provider now. And when you buy the SaaS, the software as a service, all the security requirement relies with the service provider. You are only worried about your data. That's all. Okay, so cloud applications. Cloud application, when somebody says cloud application, this typically means software as a service. Okay, so that's the first point there. Software as a service resides here, SaaS resides here. Then most common cloud and many providers of cloud different services. So this is a most common method of the cloud offerings. Most of the companies, when we talk about cloud applications, you'll see lot of applications, lot of vendors. There are huge number of providers in this category compared to IaaS and PaaS. And then what is advantage? Advantage is I gave you an example that earlier where you used to host your application in your own data center and then access those over the VPN or some other method from your sites. Like if you take an example of a mall, so every mall has to connect to their backend. Those hundreds of their terminal, the billing terminal has to connect to their backend to update the billing and get the data, right? So if there's something wrong in the network, if the internet is down, this whole thing goes for a toss, right? So if you have SaaS provider, if you're having internet service connection problem, just switch your internet connection and then your system will start working again. And you don't really need to worry about hosting that particular application anywhere. It's all done by the service provider. Disadvantage is compared to the traditional software, this provides you limited controls, limited functionality, and you have very limited access or the control to underlying technologies. So you really don't get to change anything on the underlying technology perspective. All you can do is just change your data, the look and feel of the portal. That's all. So Cloud Pro and some of these providers are listed on the right side. You can see the logo: Office 365, ServiceNow, Workplace, Salesforce, GitHub, Dropbox, Google Drive. All right. The next is Cloud Platform. That's again PaaS. So you can see on the right side the examples: Amazon Beanstalk, Oracle Cloud Platform, Google App Engine, Salesforce, Heroku, Amazon, Azure, Force.com. These are the providers of the cloud platform. So I have already explained what it is. So I'll go to advantage and disadvantage now. Advantage is good for the developers, more control than the application clouds and tightly configured. So it says application clouds, forget about that term. More control than the SaaS providers you get here. When you have your own platform, you get more controls than the SaaS providers, but less control than the IaaS providers. It's good for the developers. They can code and build their codes anywhere from anywhere. They don't need to sit in the office anymore, and that somebody don't need to manage the data center anymore. Disadvantage is restricted to what is available. You can't do much. So for example, if a platform is just providing you Linux based servers, you can't have Windows based servers. That's a limitation. You can't do much. You can't explore more than what they are providing. You just have to be limited to what is given to you. So that's all. Infrastructure as a service, again, it's the delivery of technology infrastructure as an on-demand based scalable service. Metered billing, usually billed based on the uses, usually multi-tenant virtualization environment. So multi-tenant virtualized environment means, see, the data center which AWS has, they have millions of data centers, for example, right? But in each and every data center, they have they are providing the service to different customers. So you might be having your server in that particular data center. Some other customer may be having their servers as well in that data center. So segregating your servers with them, so you don't see their data and they don't see your data. If their server gets hacked, your servers are not impacted, right? To ensure these things, the multi-tenancy comes in picture. This term usually multi-tenant virtualization environment. This means that your environment is separate from the others. There are multi-tenant, there are mechanisms to make sure that the data is segregated between these customers, and usually they don't interfere with each other. Can be coupled with managed services for OS and application support. Um, this is nothing. It just means that managed services for OS and application support. It means that They are just providing the infrastructure. On top of that, you can run any OS you want, and then any application you want. So basically they will, if you have any problem with the operating system or the application, you need to fix those problem by yourself. If there's any problem with the infrastructure, like the network pro related problems, if one of the server is not responding due to the underlying infrastructure problem, that's something they are supposed to take care. Advantage is full control compared to PaaS and the SaaS environment. In the PaaS, you only get the control of the platform. In the software as a service, you get only the control of the software of the data, right? But in the infrastructure as a service, you get the control of the platform and the application both, in also the underlying operating system. Disadvantage, it's quite costly compared to platform as a service and software as a service, and there are very limited market leaders in this, very little competition in the market. So that's one of the reason of the prices being high. So as you can see, the logos are very limited on this slide compared to the previous two slides. I'll just go back to show that to you. See, if I came to platform, the number of logo increases here. If I go here, this the number of logo will increase more here, but I have kept it limited. So I can put another 10 15 logos here. So that's the beauty of it. In the SaaS you have more providers. In the past you have lesser than SaaS but more than IS. In the IS you have the least provider than compared to others. So very less options in terms of switching from one vendor to another, and the prices are of course premium, but on the other hand you get a lot of good features. You don't have to worry about the infrastructure and everything. Okay, if you have any questions so far, please write those on the chat. I'll just pause for quick 1 or 2 minutes, and then I'll start talking about the deployment types as well. All right, so this is the third item provided by NIST. So far, we talked about essential characteristics and offering methods, and now the deployment types. So there are four deployment types: private clouds, public cloud, hybrid cloud, and community cloud. So private cloud are the cloud owned by a particular organization. So if it's a company owned, like, so for example, if it's your own company which has its own cloud, that's called private cloud. So you are responsible of managing the infrastructure, you are responsible for managing the platform, and you are responsible for managing the software. And when do you do it? When you have multiple departments or multiple locations accessing the same have the requirement of cloud, but you really don't want to expose your network to internet. You are into banking or something. That's where you have private cloud. Then comes public cloud. The cloud providers we saw in the earlier slide, Azure, AWS, etc. Those are called public clouds. Then you have hybrid clouds. Hybrid cloud is a mixture of private and public cloud. So a company may choose to have a private cloud as well as a public cloud, where any service which is not that critical, the data is not that sensitive, they host that in the public cloud, and anything which is critical and more sensitive, they host that into the private cloud. So it's a mixture of both the offerings where the company choose to use both of these methods, and then they decide what kind of data goes where. The last one is community cloud. Community cloud is same as private cloud. So in private cloud, it was managed and owned by a single organization. In community cloud, what happens? Multiple companies or multiple organizations, they form a community and they have a cloud. So, for example, uh, if all the doctors of Bangalore they decide they should be having a cloud, what they will do, they will form an organization, and that organization will create a cloud and will give access to all these doctors. That's a cloud, community cloud. So a community cloud is a cloud created by a particular community creating common goals in the mind. These are the four types of cloud deployments. Okay, benefits. Benefits of the cloud. It's easy to use. Deployment is usually done by a click of mouse or a couple of API calls. You don't need to worry about any cabling, any screwdrivers, any racking, unboxing, buying hardwares, etc. Middle of the night, that means even in the middle of the night something goes wrong, you can fix things from your home. You don't need to go to office. If in the middle of the night you need to create more servers, you can do it by couple of clicks. You don't need to really go to office or data center for that, and do it yourself from anywhere. Since you have the control of creating new servers just by few clicks, creating new applications, creating new platforms, you can do it from anywhere and do it yourself. You don't need to actually depend on any of the providers. You don't need to call Amazon or Azure to set up servers for you. These are just more advantage, flexibility and storage. Storage of the file in the cloud allows for the development and easy access of the office files from anywhere. You don't need to sit in office. You can access those files from anywhere, and control your infrastructure with your application demands. You can control your the infrastructure. As I said earlier, whenever your requirement goes high, you can spin up more server. Whenever the requirement goes low, you can delete the whole servers automatically. You don't need to do it by manually. You can create scripts. You can create policies, so this scale up, scale down happens automatically. No need to purchase expensive hardware. Yep, that we covered already. Reliability based on high quality hardware. Since these hardware which are used by these providers, they are very high quality hardware, so there are very less chances of failure. And design for failure, automatically spin up replacement. So you can create a policy when one of my server fails, you can create more another server to take place of that, and then you just migrate the entire machine to a new one. And you have a choice to use multiple clouds like public cloud or private cloud. You can use GCP and Azure at the same point of time. Okay, these are the more benefits. Time saving, easy access, it's fast and easy in contrast to requirement of downloading and installing software. They have high huge internet bandwidth, so if you need to upgrade a server, it happens in seconds. You don't really need to wait for long time to upgrade your servers or upgrade your application. Cost is reduced and all other things. I'll just forward here because we are running out of time now. And the last point is no need to buy anything in advance, pay as you go. Like Salesforce company changes from $5 to $25 per month to its services. That means if you just use five features of that particular service provider, you pay $5. If you are using another 25 features from that company, then you pay for those 25 new features. So that's how the metered billing works. Okay, so challenges of cloud computing. So the challenges are like, first is privacy, right? Since you are hosting your data somewhere else, that means you are trusting somebody else for your data, right? So take an example. If you are a bank, you have your credit card numbers or customer data hosted in a public cloud. If something happens that their servers are hacked or that there a breach happens, your data gets leaked as well. So that's a privacy concern, right? And then again, if somebody wants to write an agreement with them, have a contract with them, that if any point of time any breach happens, their data should not be leaked. That's pretty complicated because the contract terms they write is pretty complex. You can't really understand them. Okay, data availability. So data availability is the access to this data and the resource typically happens through internet. So for example, if there is an internet outage in the country or in your location, there is no way you can go to the physical data center and access your data. You have to be on internet to access the data. Then next comes traditional security. Cloud application integrating platforms are not securely created. So what happens? These new infrastructure they have their own challenges, right? So our traditional security requirements, what our traditional security engineers use to provide controls on top of it, these are not valid anymore. They have to think something else. So now the technologies are changing, so the security requirements are changing. So you have to adopt to new security methods to make sure that your data, your infrastructure in the cloud stays secure. We'll be having another session on the cloud security where we will talk about this particular topic. Privacy and controls. Again, it's the same thing. So now the solutions. So what are the solutions for the privacy? So you write a very tight SLA that if some breach happens within this much time, the data is actually recovered. And you mentioned that within 1 hour your server should be back and you should be having your data recovered. You should not lose any data. And then you have accessibility. uh, it's just saying that shut down any unused services, update your servers on time, update your applications on the time, so you don't face any downtime when any application is unsupported anymore, or due to any flaw in the old versions you don't lose access to your applications. So these are typical old solutions, nothing much interesting here. Authentication says that you should be using encrypted protocols wherever possible. You should be authenticating your users to give them access. So if you are having an application, you should make sure that the user log in through an username and password, and on top of that you enable the multi-factor authentication, or where the user logs in by an authentication code created on the authenticator app, or they receive an OTP and they supply that OTP to log in. Web application. So X10 is a new language. So this achieves better use of cloud capabilities in massive parallel processing and concurrency. So uses of X10 language is more recommended when you use cloud services. Data verifications. So as I mentioned earlier, that to data for the data verification, you use data isolation or the multi-tenant environment. So that's already done by the cloud service provider. This is just a point where I want to say that you need to make sure that whatever service you are buying from a cloud provider, make sure that the multi-tenancy is there. That don't mix up your data with somebody else's data. You need to read their agreements carefully. You need to ask them that do they have multi-tenancy in their environment? Is your data segregated from others? Okay. um, so this is now I'll go very fast in these slides. I'll just wrap it up in another 5 minutes. So in the major services in our traditional static data center, so see, this is your demand. But to fulfill this demand, you need to have this much capacity. This is your capacity. So what is waste? This is the waste. This particular resource is waste here, right? And there may be a spike at some point of time, but usually this is what you see in throughout the day. So you are over provisioning and underutilizing your hardware. That happens in the static data center. But what happens, what are the drawbacks of these things? We'll talk about that now. So in the over provisioning, you waste resources, you don't utilize them, and then what you can do, you can cut down your resources from here and you make it here, right? So you only achieve what you have. But then again, this much data is waste when you have low requirement. Let's see in the next slide. So when you cut down your resources, what happens at some point of time when the requirements goes above, right? When your this is your requirement and the demand goes high, you lose revenue because a lot of customer will not be able to access your environment anymore, and you will lose users as well, because if your site shows 404 errors back to back, then the users will not return to your site anymore, right? So now in terms of cloud, what happens, your resources change as your demand changes. See, this is the old data center where the resources used to same, right? Because your hardware is limited. You have 10 hardware servers, so you can't that cannot really change as the user as the internet traffic increases when it hits your server, right? It will always be same. So either you have underutilization or you have overutilization, and you have problem in both cases. But when you have data center in the cloud, you create a policy that as the requirement go increases, you increase your resources. As the requirement decreases, you decrease your resources. So even in the cloud, in the one single day itself, You can create policy that every 10 minutes your the servers is spin up and delete. So you save a lot of money even in one if the next hour your requirements are lower than the previous hour, you have less servers than the previous hour. So you are saving a lot of cost here. Okay. So security issues to consider before moving to cloud. It's like you need to be sure who owns the data security responsibility. I'm not going to explain cover these topics. You can read about this. I'll just summarize them here. So you need to understand where is your data stored, which location. So any local jurisdictions doesn't impact the data availability. You need to ensure who owns the security responsibility of the data and the infrastructure. You need to ensure what are the service level agreements, how soon the network recovers when there is a failure. You need to ensure that what are the multi-tenancy offerings in that particular service provider. You need to make sure that what are the regulatory certifications the service provider has, right? You need to ensure that are they on the latest technology, like are they adhering to all the requirements, the security requirements, and are the underlying hardware secured enough from the physical theft? So these are the points you need to make sure. These are the points which I have mentioned there. Feel free to read it when I share this presentation with you guys. So conclusion of this particular discussion is one thing: the companies and the people were always confused whether moving to the cloud is a right decision or not. Some At some point of time there can be challenges where you don't your movement to the cloud cannot be considered as the right movement, because the data you store in the cloud might be too sensitive for you to store in the cloud. At And for the other organization, it might be a very right movement, very required movement, where you don't have very sensitive data to store in the cloud, but you have high requirement of the availability. So let's take two examples. One is State Bank of India. Can they move their infrastructure to the cloud? If they want to move to the cloud, they have a lot of securities to think about, because they have financial information stored on all these servers. They cannot really just simply move to the cloud. They have to think about it. They will be at least 10 years back than the industry, where other industry has already moved to the cloud, but the banking industry will still be on the on-premise network as much as possible. And when you talk about the e-commerce, can the e-commerce service providers move to the cloud very quickly? Yes, because they don't have much financial data stored on these services. All they have their web portal where the users go, place some orders, and then the orders are tracked on those platforms by their serve delivery agents, the customer, and the backend warehouse, right? And then all the money and all the financial transactions are handled elsewhere. So you typically have nothing to lose. For you, it's very safe decision to move. So, and you really have to, if you are an e-commerce company, you really have to move, because what happens when you launch an offer or the big billion days, the requirement of the resources are quite huge. You cannot have your physical data centers to accommodate that requirement. So for example, in a normal day, if you have 100 servers, on the big billion days you would require at least 1 million servers, for example. And you can't configure those many servers in such a short time, right? So you need to have the cloud in place, where the elasticity and the data scalability happens automatically, right? And then what happens when there is no uses, like right now, if you see due to the COVID-19 lockdown, there is no uses of the e-commerce sites anymore. They are not accepting orders anymore, so we are not visiting their sites anymore. So if they had hundreds of servers in the normal business time, now they don't even need 10 servers to fulfill the user requirements, right? So now the number of servers should be reduced to save the cost. When the servers are idle, there should not be cost for them. So in such scenario, the organizations have to make a move. So depends on what is your organization, what is your business model, and how sensitive is your data, how critical is the security for you, how critical is the availability for you. Depending on all those, you make a decision whether to move to the cloud or not. So yeah, that's all from my end today, and thank you guys. Now is the time for the question and answer. Let me see if there's any questions. I'll try to answer them now. Okay, can you guys hear me? I think I lost connection for a while, so I should be back. Let me see if there's any questions. I'll try to answer them now. Okay, so Rahul asks, want to cloud certified? What will be path? So Rahul, please give me more information. What do you want? Like you want to be certified on the cloud infrastructure or cloud security? And what is your current job? What do you expect from the certification? Do you want a career movement or what do you want? Now, more about AWS is asked by the Sahil. Sahil, as I explained earlier, we will be having deep dive session into AWS and all. This is not a certification class, so I will not be going into that much details. And as of now, probably we'll be having more in-depth classes later. So I'll explain more about AWS in future, but for today, this is not in scope. So what we have spoke today about the general terms, how the cloud works and all. But then in terms of how do you create a server, how do you run your workloads, all that's a another long topic, and we need more time to talk about that. So Rahul, for you to get certified, you can go for AWS Solution Architect course. That's really good one. You can get certified on that. So from the solution architect perspective, AWS Certified Solution Architect course will really help you out. And if you want to be certified into the security, the industry best standards, then there are CCSP, Certified Cloud Security Professionals. You can go for that. Then there are other as well from ISC2. You can explore that. For Sahil, I'll try to conduct some class on AWS as well, but not now, at least not in next 2 months. But please stay tuned to the channel. There will be a lot more other topics which will be interesting for you and will be close to AWS. And soon, when we talk about AWS, it will start making sense to you. Okay, Umesh, are your questions answered already? Please let me know if you need more information. So Umesh asked, is public cloud secure or not secure? They are secure, but what happens a lot of time the administrators make some mistakes while configuring them, right? They leave some ports open, some they give over excessive permissions, right? So because of that, the security is compromised. So our administrators needs to make sure that those things are configured properly. If there's no misconfigurations, these are secure. And on demand basis pay as you go or the metered billing, can you explain more? So it's the same thing. Look at your water consumptions, look at your electricity consumption, you only pay for what you use. So the same thing applies in the cloud. So if you have 10 servers at the moment, and the next time when you just delete 5 of them, you have just 5 more servers running, and then the next time you create another 15 servers, now you have 20 servers. So for the duration where you had 10 servers active, and for the duration you had 5 servers active, and for the duration you had 20 servers active, you only pay for those resources which you utilize there. Okay. Any further questions? Please write in the chat. Umesh, please be specific about your question. How about multi-tenancy? What do you mean by that? So multi-tenancy is to secure your data. If a provider is having multi-tenancy, that makes your data, your environment more secure. So that means the cloud is secure. You don't need to worry about it. But see, the data multi-tenancy is, see, on one physical server, as I explained earlier, that these servers are quite huge, and there you can create hundreds of virtual operating system. And these hundreds of these servers, let's say 20 servers are required by you, rest 80 servers are given to me, right? So we both have the same infrastructure, same physical server in the underlying hardware, but on top of that we have our own separate virtual servers, right? The 20 servers are assigned to you, 80 servers are assigned to me, but the hard disk which stores the data is same, right? And then the logical partitioning is done on those hard disks, for example. So the operator needs to make sure that the hard drive date partition which is assigned to you and the which is assigned to me, it's separated in some way, in a software way, that your data is not actually shared accessed by somebody else. I can't access the partition assigned to you, and you can't access the partition assigned to me. So for example, in your Windows, if you have multiple users created in your Windows account, right? Window your laptop, there are, if you go to users folder, you have users folder for different people. You can only open the folder for yourself, but to access the folder you need of other user, you need to get give administrative privilege. So similar methods are deployed to maintain that particular behavior, that you don't access something what you are not supposed to. So that's called multi-tenancy. So in multi-tenancy environment, you won't even get an option to access somebody else's data. You won't even see that there is another user. For you, it will be just like you have your own servers there itself. Nobody else has servers there. So I hope that's clear. So see, it says logically isolated, but physically integrated. So logically these are isolated, but physically you're on the same network. So that's how the environment is separated. So if you look at multi in the single tenant, what happens? One user owns one application, and for that application there is a separate database, right? So if there are three users, they have their own application and their own database. They are not shared. But in multi-tenancy, what happens? They all have three database which are separate. The data is stored somewhere else, but the application platform is same. So if we take an example of AWS, right? In AWS, what happens? You all log into the same portal. We all go to console.aws.com, right? And we log in there. So the console is same, the application is same. Then on the back end, there is different sort of these environments. So it can be like physically, these the data can be segregated, or it can be virtually data is segregated. Usually, it's segregated virtually, not physically. I hope that's clear. All right. So thank you guys for your time today. It was nice talking to you all. Okay, and please subscribe to the channel and share the channel and the form with your friends, so we will be having more sessions. And that's all for today. And there is no session scheduled for today or tomorrow. I don't have any plans as of now. I'll drop an email to all of you for our next class. probably a day in advance whenever we plan it. So it will be probably we will have another class in the next week. In the weekdays, I'll try to do that. All right. Thank you guys. Bye.